Good morning. In this class, we see about how is working the Cupola furnace and the blaster furnace. Okay, so we have to last class we discussing about how is a sand molding is a different types of pattern we have to making for the sand molding process. So the main important you have to pouring the material into it. Then only the pattern will be making. Okay, so here the melting of a furnace the name is called as a one name is called as a Cupola furnace. The another one is called as a blast furnace. Okay, so the next one is so this is the simple construction how the molten metal can be extracted and is a pour into the molten places. Okay, so this is the simple view of your understanding purpose. The furnace can be burn the metal and this can be above the is 1000 degrees Celsius based upon your metal graded. Okay, so and then is a pouring material is can be formed in a storage then is a pouring into the mold cavity. Yes. So here, what are the construction we have to making for the cupola furnace? So generally, the cupola furnace is like a cylindrical shape and placed in a vertical. Okay, and it also made up of the steel and its size is approximate diameter ranges from 0.5 meters to and 4 meter. Okay, then internal walls are lined with the refractory brisk. Okay, yes. So this is the look like a cupola furnace. This is the part we have to consider. So what are the main parts we have to for the processing for the cupola furnace? The first of all, there is a spark arrestor, okay, and the charging door, air box, tires, and tap holes and slag holes. Okay, so this is the simple construction. That is 2D diagram of cupola furnace. Okay, the first of all here the spark arrestor. Okay, is the bottom like area. Okay, so here the tire and the fitting hole and drop bottom is also there. Okay, and also legs will be there. The leg will be holding the each zone. For example, here there is a two zones. We have three zones. We have to notice down. It's like a main important is a compression zone. Is a above the wall level. Okay. Then is a, again second zone is we call it as a melting zone, and is the third one is called as a preheating zone. Then last one is called as a stag zone. Okay. So these are the different zones we have to placing the cupola furnace. Okay. So these are the first of all we have to pouring the first of all we have to collect the waste materials like a aluminum based grader. Okay, and it's storing it and it's filling into the cupola furnace. Then we have to using the high what is the melting point of the aluminum. They have to combustion zone can be burning the aluminum. It can be going for the melting, and also the exhaust can be go from the outside of the that is a cupola furnace. Okay, so here there is a air blasting inlet is there. So this is the reducing the is a easy to burn the easy to burn and melting the molten metal. Okay, and also air box is there, refractory lines and say steel seal and stag. Okay, these are the different types of components can be there in cupola furnace. Yes. So we have to see about what are the zones we have to use here. Okay. So here there is a zone will be a wall. The wall is a base space between the bottom of tire and the sand bed. Okay. So the molten metal is a collector in these portions. Okay. For example, here there is a sand bottom. Okay. The sand bottom we have to collect the that is a molten metal which one we want to melt it. Okay. So then this can be going for the burning zone. Okay. So it's a air is inlet here. Okay. It's like a wind box. The wind box during the wind box is using to inlet the air blast input. Okay. So this is the easy to burn the molten metal. Okay. Once we have to collect the molten metal, then we have to transferring the cases of the melting zone. Okay, so here the one is a compression zone. This temperature is approximately is like 1540 degrees Celsius to and 1080-70 degrees Celsius. Okay, so this is the called as a exothermic reaction. So there is a two reactions there, endothermic and exothermic. Exothermic is a more than heat supply. Okay, the heat supply is a greater than zero. Okay, so for example, if you have a high heating process supply is called as a exothermic reactions, and also here the carbon and oxygen, okay, is a mixed with the carbon dioxide plus heat and the silicon plus oxygen plus is combined with the silicon dioxide and the heat. Okay, so the third one is a manganese is oxygen with the manganese oxide and plus heat. Okay, so this types of zone we want to recover the temperature is like approximately 1540 to 1870 degrees Celsius. Okay, so the next zone is called as a reducing zone. So this is the zone, it can be located between the upper level of the compression zone and the upper level of the coke bed. Okay, so this types of zone can be require the temperature of 1200 degrees Celsius, and in this zone they have a carbon dioxide, the change into carbon monoxide. Okay, so here the carbon dioxide plus carbon will be there in a coke, so it can be process can be done into the finally we have to take as a carbon monoxides. Okay, so the next one zone is called as a melting zone. Then in this zone we have to melting is done and is located between the preheating zone and the compression zone. The following reaction take place in this zone. Okay, for example, here iron plus carbon monoxide is a combined with the iron carbon and the carbon dioxide. The carbon dioxide can be exhaust, the only we have to getting the carbon monoxide. Okay, and the preheating zone and a stag zone. Okay, so what is the purpose of preheating zone is this zone is start from the upper end of the melting zone and also is a continuous up to bottom level of the charging door. The objective of this zone is a preheating charge from room temperature above the 1090 degrees Celsius before entering the melting charge into the melting zone. The last one is stag zone. The stag zone is the empty portions of the cupola furnace. Is above the preheating zone is called as a stag. Okay, it is a provided passes to the hot gases to go to atmosphere from the cupola furnace. Thank you.